All right, so now let's keep going and we'll learn some of the methods of actually solving without needing to graph. So the first method we're going to use is called substitution. So I'll call this method 1. So I have a list of steps here. These steps would apply anytime you use this method. With substitution, the idea is you want to have a variable isolated by itself so that you can plug it in or substitute it in to the other equation. So when you're using substitution, see if there's a variable that has only 1 as a coefficient. In other words, look for just an X or just a Y. That's going to be the variable that will be easiest to isolate or get by itself. And then you can substitute into the other equation. So for example 1 here, 3x plus 4y equals 14, x plus 6y equals 28. We can choose to either isolate x or y. I'm going to choose x because I noticed that in the second equation, we have an x that does not have a coefficient, meaning if we were to isolate it, we wouldn't need to divide by anything, and we wouldn't end up with some fractions, basically, that would make our job a little harder. So I'm going to choose to isolate x in the second equation, simply because it's probably the easiest option. I could isolate x or y in either equation, but this is going to be the easiest one to start with. So if I isolate x, solve for x, I'm getting the x by itself. I'm subtracting 6y on both sides. So then I would have x equals negative 6y plus 28. So that's my second equation rearranged. So I isolated one variable in one equation. That's step 1. Next, what we're going to do is substitute into the other equation. So that means I'm going to plug this expression in for x in the other equation. Okay, so I'm going to be writing all over this slide here, and then I'll erase when I get to problem number 2. So I'm just going to pause and make some space. I'm whiting out problem number 2, but we'll come back to it. All right, so we're about to replace x in the first equation. So instead of 3x, I'm writing 3 and then parentheses, and then we're substituting for x using the other equation. So we had isolated x, and we had gotten x equals negative 6y plus 28. So I'm replacing x or substituting for x with that expression. So that's my 3x, and then plus 4y equals 14. So now we have one equation with one variable, and we can solve that new equation. So we did step 2, we're now in step 3, solve the new equation. So I'll distribute the 3, negative 18y plus, let's see, 3 times 28 would be 84 plus 4y equals 14. Now I'll combine like terms. Negative 18 plus 4 would be negative 14. So negative 14y plus 84 equals 14. I would subtract 84 on both sides. That's negative 14y equals negative 70. Divide both sides by negative 14. Y equals positive 5. Now that we have y, we need to go back and find x. So we solved the new equation. Now we're substituting again. So now you pick either one of those original equations to plug in for y. So we got y equals 5. Pick either equation. I'm going to go with the one where I had already isolated x. I think that will be easier to plug into because x is already isolated by itself. So I'm now going to replace y with 5. So here's some more substituting. X equals, instead of negative 6y, I'm doing negative 6 times 5 plus 28. So negative 6 times 5 would be negative 30, plus 28 would be negative 2. So my final answer as an ordered pair would be in parentheses negative 2 comma 5. It's important that we put x first and then y. Okay, so pause there if you need to get caught up, but that's an example of using substitution. So again, we isolated one variable, we substituted into the other equation, solved to get one variable. In this case, we got y. Then we substituted back into one of the original equations, solved for the other variable. We got an answer for x. I don't always do this very last step, probably like many of you, but for now, let's make sure we check our solution into both original equations. So I'm going to take my ordered pair, -2, 5, and check it in both equations. Okay, so I'm pausing again. I'm going to go to a blank screen to do this checking process, and then we'll move on to number 2. All right, so we're about to check our solution. The solution we got was -2, 5. I'm first going to check it in the first equation, replacing x with -2 and replacing y with 5. And we just need to check to make sure this equation is true. And we need to check both equations. So 3 times -2 plus 4 times 5. So that's -6 plus 20, which is 14. And yes, 14 equals 14. So that works. So that means we know that solution works in one equation. We do need to check both to be absolutely sure. So here's our second equation. X plus 6y equals 28. So that's -2 plus 6 times 5 equals 28. -2 plus 30 equals 28. And yes, 28 equals 28. So it checks out. So that's number 1. And now let's try number 2, another example of substitution.